Okay, what did you guys decide? Let's hear your thoughts. We'll just go in order here. What did you guys think A is? A is the absolute min. Hey guys. It's a polite way of saying stop. So A is definitely the absolute min. Don't you look at the graph and you say that is the lowest point on the graph? Like that's literally how you identify the absolute min. There's no point lower than that. Okay, so then what do you guys think about B? Relative max, absolute max. It's definitely not any kind of a min, right? That's pretty clear. So what we'd say here actually is relative max. And here's why I would say that. The reason why is if you do zoom up here and you look, if you were to try to draw a horizontal line straight across there, there are some points on the right that are higher than point B, aren't there? Yes. And so that means that B cannot be the absolute max because there are other Y values that are higher. But it is a relative max because it is a relatively high point. It's a peak as opposed to a valley. Make sense? Yeah? Okay. So we'll do a lot more with the relative extrema later, but take a look at C. What would you guys say about C? It's neither. Yeah, none of the above. Agree with you. And it's not that C is totally unimportant. C is actually what we call an inflection point. We'll study those a little bit in chapter 3 as well. Please notice how to the left of C, do you see how the graph there is like the concavity is facing down? But then on the right, the concavity is facing up. That makes it what we call an inflection point. We'll deal with that stuff later, but that's just sort of a preview. How about point D? It's a relative min. Yeah, that's correct. Because it is a low point, but it's not the lowest of the points. There we go. All right, so E. What do you guys think E is? So isn't it true that E is a point of non-differentiability? Yeah. Isn't it a sharp-looking point right there? Yeah. But it's still a relative max, right? It's a relatively high point. It's like a jagged mountain as opposed to a rounded hill. Doesn't mean that it's not a max. It's just a relative max. And finally, how about F? It's a relative min. Agreed with you on that one. Finally, we get to G. G is where things get a little more interesting. What did you guys think G was? Neither. Okay. None of the above, I guess, right? Because there were 4 things to consider. None of the above. Huh. Are you guys sure it's not an absolute max? Because doesn't it seem to be the highest? Open circle, right? There's a hole there, right? So what does the open circle really mean? It means it's not there. Okay, so we look at that and we say, all right, open circle means that it's not there. So G is not the absolute max. So what does that mean about this graph as far as absolute maxes? It doesn't have one. Okay, let's talk about that. That's a good question. So, like I did before, couldn't you draw a little horizontal line across here and say, hey, there are some points that are near G that are higher than B? Right? So, say, fair enough. I agree with you. So, let's think about this a little bit more. I'm going to zoom in a little bit. What do you think? What do you think about that point right there? Can you see it? Is that point the absolute max? No. Okay. I'll use a different color here. How about this point right here? See that yellow one? Can you see it?
No, not really.
Okay, I'll make it blue. Look for the blue point. Is this the absolute max? You see it? It's right there. How close can I get to G? So is there ever a time when I can say, and I'm there? There's not. So the answer is, I think what Dixon said, there is not an absolute max on this graph. There isn't. If you wanted to like redefine it and just like cut the graph off like right there and say, well, I want my graph to end right there, then you could say, all right, well then that actually is a filled in endpoint, and that is the absolute max perhaps, right? But the way that it's currently drawn, it does not have an absolute max. It does have a min though, doesn't it? I want to remind you at the very start of 3.1, we talked about this thing called the extreme value theorem. Doesn't that sound a lot like maxes and mins? Extreme values, right? The extreme value theorem essentially says this: if a function is continuous on a particular interval, then it guaranteed has a max and a min. But if a function is not continuous, you cannot guarantee that there's a max or a min. This is kind of an example of this, right? Do you see how it's not continuous on the whole interval? So you can't guarantee the max or min, and it actually does not have a max. And so just a little example of the extreme value theorem. So chapter 3, there's enough going on. I'm going to summarize each section or most of the sections for you at the end. So take a look at the key takeaways. See if this makes sense to you based on what we've been doing. When finding absolute extrema of f of x, the candidates are endpoints and critical numbers. That make sense? Critical numbers are places where f prime is 0 or doesn't exist. And then when you're testing those candidates, you're going to plug each of those into f of x to determine what the max and the min are. Does that seem to go with everything we've been doing? I hope it does. That's kind of a brief summary. That's all of 3.1 and just like a quick little snippet of information. So if you want to go back and reference it, I mean, this is where you could just get a quick sense of what's going on. Okay, so let's talk about the speed trap project, okay? So you guys did a wonderful job with that, and I think we'll be able to use that quite a bit here. So you see Rolle's theorem at the start of 3.2? Yeah? We're going to skip that, and we'll come back to it in a second. We're going to move on to this mean value theorem. And by the way, I got to say, you guys know how every rule has like... on the closed interval, continuous on the closed interval, and differentiable on the open interval. So this is basically saying, if there's not a wormhole, teleportation thing going on, or you don't have a car that can like instantly change its speed, like in no time at all. So it's saying, if there's no wormhole, there's no teleporting, and you don't have a special car that can like brake instantly or accelerate instantly, then, those two things are true. Then on the open interval, so A to B, so in other words, like on your trip, from point A to point B, then there exists some number C within that interval, and here we go. Here's what our police did yesterday. There exists some number such that f prime of C, that would be the instantaneous speed or instantaneous rate, equals, what is the thing on the right? Police?
Equation.
No, the thing on the right of the equal sign is just an expression. The whole thing's an equation. But what's the thing on the right?
Distance over time.
Also known as? Average rate. There you go. Average velocity or average rate. This is what the police did. The police said this. We don't really know how fast you went at any particular point. We don't know. We do know. We know how fast you went up there. We know how fast you went down there, but we don't know what happened in between. But here's what we do know. We know that your average rate was whatever, some cases higher than others, but we know that your average rate was this. So, because your average rate was this, we know for a fact that you actually went that average rate at least once, with the one exception of if you have a teleporting car. So do you see how all this is just the speed trap project in math words? I hope you do. I hope you do. So what I'd like to do here also is draw a picture for you. And I'll just kind of squeeze this picture in over here. So check this out. If we take this mean value theorem and we try to apply it to a picture, here is a graph right here. And let's say that this is A, this is B. So let's say that, here is f of A, here is f of B. If I were to connect those 2 points with a dotted line, what would that dotted line represent? Yeah, secant line slope, right? So that would be the average slope between the 2 points. Now, if I actually drew the graph, maybe the graph would look something like this. Something like that. Can you see any place on that nice, smooth, red graph where the instantaneous slope is the same as the average slope? See any points that maybe...
Maybe like right about the middle.
I think I'm going with like right about here. So if I drew in my tangent line, do you see how my tangent line would be parallel to my secant line? Does that seem like about a reasonable spot? I mean, isn't it, I hope it's clear, is it clear to you guys that this would be the wrong spot to identify?
Yes.
I mean, right here, look at the tangent line. That's definitely not the same as the average slope, is it? Not even close. So somewhere in the middle there, like right about there, maybe would be a reasonable spot to say, and that's where the average slope and the instantaneous slope are the same. Okay, so the mean value theorem we've done this before. The mean value theorem is simply an existence theorem. Here's all it tells you. The answer exists. That's it. Now, as to whether we actually find that answer, that's a whole different thing. And that's what the police did yesterday, right? The police said, oh, you know what, we actually want to find out what that answer is. We want to find out what your average speed is, and we want to try to figure out if you went that or not. And that's what they used to get the ticket, right? So the mean value theorem also says is, hey, the answer doesn't exist or the answer does exist. The requirements are this. The function must be continuous, differentiable. No teleportation, no cars that can accelerate instantly. Bottom line, that's it. Does the picture help a little bit? Okay. Let's take a look here. There's a couple of other things here. This is simply a restating of it, so I just left it in there. Here's a different way to think about it. If f is continuous and differentiable, then somewhere the blank slope equals the blank slope. What goes in the blanks? Yep, instantaneous slope. I'll just put INST for instantaneous equals the average slope. That's just a restating of the mean value theorem. So again, just a reminder, mean value theorem guarantees the existence of the answer, and then maybe it's up to us to actually find the answer. Maybe we do, maybe we don't, depending on the question. Okay, so let's take a look at our first example. We're going to do two of them, so take a look down below. We'll do our first example. All right, so there's really two questions here. Let's take a look at these independently. So the first sentence says, determine whether the mean value theorem, by the way, you can use the acronym MVT for mean value theorem. Everybody knows what that means, so if you use it, it's okay. I'd encourage you to do that because you're not wasting time if you do. No, because that's not the mean theorem value. That might be something, but yeah. All right, so determine whether the mean value theorem can be applied to f on the closed interval a to b. So let's determine that first. Let's decide, yes, the MVT can be applied, or maybe, no, it can't. So what do you guys think? Here is the function we're talking about on the interval there. Do you think the MVT can be applied or not?
Yeah, well, it's continuous.
Okay, so let's see here. You're saying f of x is continuous. Is it also differentiable? Okay, so f of x is continuous and differentiable on negative 1 to 1. How do we know that it's continuous and differentiable? It's a polynomial. That's actually the only easy answer here, right? It's a polynomial, and all polynomials are smooth, and they don't have any breaks or jumps or vertical asymptotes or anything like that. So that's it. You know, if you were pushed for a reason, you'd say because it's a polynomial. So because f of x is continuous and differentiable on the interval negative 1 to 1, you can say that the MVT applies. So if that first sentence was the only question, we would actually be done. We'd say, yep, the MVT applies, and here's why, moving on. Right, that's it. But it goes on to say a little bit more. It says, if the MVT can be applied, which it can, then we are going to actually go ahead and find all the values of c in the open interval so that, here's that equation right here, f prime of c equals f of b minus f of a over b minus a. Okay, so in other words, we're going to try to find the place where the instantaneous slope equals the average slope. I got a question for you. Caleb, what is our a and our b values for our question?
The value of input. But yes,
It's what?
negative 1 and 1.
Negative 1 and 1. Yep, that's our a and our b for our interval. So when you see like the b and the a within that little formula on the right, that's what we're talking about, right? We're talking about the negative 1 and the 1. So let's go ahead and fill some stuff in. I'll keep going here. You guys can kind of fill in with me. I'm going to say f prime of c would be 3x squared plus 2 equals, I'll just write f of 1 minus f of negative 1 over 1 minus negative 1. So I'm just filling stuff in where it goes, the a's and the b's and all that stuff, and I did a derivative, and so we're filled out. The remaining challenge here is to figure out what f of 1 minus f of negative 1 is, and then solve the equation. So, what do you guys think? What is f of 1?
3.
Agreed. So equals 3 minus, what's f of negative 1?
3. No,
I think it's negative 3, isn't it? Wouldn't it be negative 1 minus 2?
Yeah.
And then you'll do a plus a positive, right?
Plus 3.
Yeah, so minus 3 there, and then the denominator, of course, is just 2. So 3 plus 3 is 6, over 2 is 3. So I'm getting this, 3x squared plus 2 equals 3. Can anyone tell me the significance of this number on the right? What is that? I just circled it. That's the average slope, isn't it? So that's like the police yesterday saying, I know how far you went, and I know how long it took you, so your average speed is whatever, right? And then the thing on the left is, well, this is your instantaneous rate or speed. We're going to try to figure out when you actually sped, right? So this would be us trying to say, and we know, Noah, that you were going this fast at this time in this spot. We're going to try to find that place. Okay, so to solve this, I think the steps are hopefully fairly clear. We'd subtract 2 and divide by 3. So x squared is equal to 1/3. And then we would square root both sides. So how many times did this function speed, so to speak? How many different times did this function hit its average?
Twice.
Twice, right? Because you get x is equal to
Negative 1.
plus or minus, yeah. Plus or minus 1, the square root of 1/3. Root 1/3. You guys, I hope you guys are comfortable with the idea that it's okay now to leave radicals in the denominator. It's totally fine. So we just leave it like that. So on the left, we proved that the MVT applies. And on the right, we actually found the values that fulfill the MVT. That make sense?
Yeah.
Any questions? We okay? All right, why don't you guys flip over the page. The next one has to do with coffee. Okay, so it says hot water is dripping through a coffee maker filling a cup. The amount of coffee in the cup at time t on the interval 0 to 6 is given by a differentiable function c. T is measured in minutes. Selected values of c measured in ounces are given in the table below. So if you want to look at this from the big picture perspective, like what's happening, there's a coffee maker in a cup, and the coffee maker is filling the cup with coffee. Fair enough? When t is 0, how much coffee is in the cup? 0. Nothing, right? No coffee at all. At the end, there's 14.5 ounces. That sounds like a fairly large cup of coffee. Yeah, that's a lot of coffee. Well, I mean, for some people it is. For me, it would be a lot of coffee. For you, maybe not as much. But I mean, that's like big. Like a soda can is like 12 ounces, right?
Yeah.
So this is like more than a soda can of coffee. Sounds like a lot. I don't know. That's like a medium.
That's what my mom did.
It might be. Maybe go to 16 ounces or something. 18, 20. Okay. Oh man, so this might be smaller than a medium. That's a lot. It's a lot of caffeine and a lot of calories. Okay, so you got this table right here. But so I think, do you see the importance of trying to understand like what the heck is happening here? Like you could easily read this and not even pay attention to what's happening. There's a coffee cup getting filled with coffee. You can see the table kind of agrees with that, right? So the question is there a time t on the interval from 2 to 4? So we're just looking at a small sliver of this table at which c prime of t equals 2. I want you to justify your answer. And I want to point something out to you guys. Carefully look at the wording. Do you notice that it doesn't say what is the answer? Aren't they really asking, is there an answer? So what's your answer going to be to that question? Either a yes or a no with a reason. That makes sense? So this is a little different than some questions you've seen in other math classes where it's all about find the answer. X equals this, t equals this, y equals that. Just find the answer. Here it's like they really don't care what the answer is. You really can't find the answer. They just want to know, does the answer exist, yes or no, and why or why not. Okay, so take a minute and think about it. We'll try to sum it up here in a couple of minutes, all right? Give it a go. Since we're talking about this interval from 2 to 4, why not say 12.8 minus 8.8 over 4 minus 2? That's the endpoints of the interval, right? Kind of like what we did with Noah and everybody, all the other speeders yesterday. So we say, all right, well, 12.8 minus 8.8, this equals 4 over 2. Also known as, wow, look at that. So we have found that on the interval from 2 to 4, the average slope is 2. Now, does that mean right now that the answer exists?
Yes.
Close. There's one other thing we got to say.
Continuous.
And differentiable. So what we would say, because C is differentiable. And you know what we just set up there, because C is differentiable, C prime of t must equal to at least once on the interval from 2 to 4. And that would be that. Dylan, your question, you had your hand up a second ago.
I was giving you a good rock and roll.
Oh, the rock and roll.
Yeah,
I appreciate that.
no problem.
So Alex, you were saying, I kind of want to make sure my explanation is good. What do you think? Did you do something like that?
I forgot to mention differentiable, I said continuous.
Okay. And you know, the honest truth is, if you don't mention differentiability, doesn't that leave the door open for someone to say, wormhole, I teleported from one spot to the next? That leaves that door open. But if you say, that's not what's going on here, and we know that based on the description, right? It says a differentiable function C, right? So we know that based on the description, then we can like really tighten it up and say, nope, teleportation is not allowed, therefore C prime of t has to equal to at least once. Does that make sense? So do you see what I mean? This is looking for the existence of an answer, not, and the answer is, whatever. Yeah.
If it did say given by a differential function C,
It's either a badly worded question or the answer is, we can't know. Like if it didn't say differentiable, honestly, you could answer this by saying, there's no way of knowing. Maybe it does, maybe it doesn't, but we can't know because we don't know if it's differentiable or not.
is there not a way you can figure that out?
Not based on this,
Okay.
because it just says C of t presented as a table. We don't know. This could be one of those step functions, right? Or who knows? It could be lots of different stuff. But since it's differentiable, then we know that it's smooth and continuous.
So if it didn't say differentiable, could we say there's possibly wormhole?
Yeah. If it didn't say differentiable, you could say, like when it really is saying, like, it's saying, is there an answer to this equation? Is there a place where C prime of t equals 2? If it didn't say differentiable, you could safely and logically say, I don't know, and neither do you. There's no way of knowing. There is no way of knowing. They word their questions quite well. I don't think you would find something like that. But if you did, you could say that. Because differentiability, MVT completely hangs on differentiability. Totally hangs on that. Yeah.
So if the average was like 2.2,
You couldn't say it.
would you just say like, there's no way of knowing?
There's no way of knowing.
But you can't prove that it didn't happen.
You can't prove it either way. You can't say yes it is or no it isn't. You just have to be like, nah, I don't know. There's no way of knowing for sure. But perhaps there would be other, if you had more information perhaps, but given the information, you really couldn't.
So if it was 2.2, you'd say we don't know.
Yeah, you just say,
So
but I don't think we'll ever arrive at that place.
Well, my second question was, then is this a yes or no question or a yes or maybe question?
No, it's a,
Like, is there an ever
Yes,
possibility
no,
where
or
it's a no?
yeah, I guess you could throw a third category of we don't know.
When would it be a no instead of a?
If you got 2.2,
So that is a no.
or if you got if you said it's differentiable and 2.2, then you could say no, like no, because there's no way of knowing,
Okay.
right? Yeah.
Okay.
Yeah. Don't overcomplicate it. It's really a yes or no question.
Okay.
If you found 0 to 2 and found that average and found it to be like 1.8,
Yeah, you could do an IVT possibly. That would be an IVT strategy. Yep.
would that work?
Yeah, conceivably. Yeah, that's why I was saying there might be some ways, depending on the information you had,
Okay.
it might be able to do it, depending on how it's presented. Luke, that's actually a pretty deep thought. Nice job. Very good job. Okay, let's finish this up by going back to Rolle's theorem. Guys, I think you will find that Rolle's theorem, listen, I think you'll find that Rolle's theorem is simply a rehashing of the mean value theorem. So let's go back there and check that out. Right. It says, let f be continuous and differentiable. Isn't that just like the MVT? Okay. There's one other requirement that f of a must equal f of b. What this is talking about is that, the a and the b still stand for the endpoints of the interval. F of a equaling f of b means that the y value on the left end and the y value on the right end got to be the same. That's one other requirement. And if that's true, then there is at least one number on the interval such that f prime of c equals 0. I want to draw you a quick graph. I will draw on a graph here real quick to kind of show you that. So check this out down here. So you got your interval a to b. Are we good? Giggly's going to go away eventually? Okay, awesome. So here is a, here is b. There's the interval right there. Do you guys notice how f of a and f of b are the same? So I'm going to draw in a little dotted line right here. Doesn't this dotted line, just like before, doesn't that represent the average slope between the points? And what is the average slope on this one? 0. So the average slope is 0. So this would be like the average speed is 0. Then what that means, this is an MVT way of saying it, if the average slope is 0, then what has to happen somewhere in between? Have to have it? Yeah, you actually have to hit that average slope. So somewhere in between, there is an instantaneous slope of 0. And think about this. Instantaneous slope of 0, isn't that just another way of saying, Ben, you with us?
Yeah.
Isn't that just another way of saying horizontal tangent line?
Yeah.
What happens at horizontal tangent lines?
Slope is 0.
Slope 0.
Slope is 0, and so you could have maximums and minimums, critical numbers, right? You could have things like that. That's why this is important. So, I just want to do this last question here with you guys really quick. We can fill in some of the blanks next time, maybe by way of review, but I think this will be a good way to tie this up. So check out down below here. It says, let f of x equal x to the fourth minus 2x squared. And it says, find all the values of c in the interval -2 to 2 such that f prime of c equals 0. So first of all, is this function here, is it continuous and differentiable?
Yes.
Because it is a polynomial. And then also, does f of 2 equal f of -2? It actually does. If you do the math, it ends up being 8 equals 8. So because of all that, you know that Rolle's theorem applies, and here's what we do. We say f prime, which would be 4x cubed minus 4x, must equal the average slope of 0. And finally, we solve this. I'm assuming you could solve this pretty easily. What would you do? Factor out what? I think factor out a 4x. What's left over? Minus 1. And doesn't x squared minus 1 factor again? You guys remember what that's called? Nice, a difference of squares. So you would get 3 different places. They would be x equals 0, x equals plus or minus 1. Do you guys remember how quartics look like either m's or w's? So how many potential turnaround points does a w have? 3. How many zeros of f prime did we get? 3. You see how that matches up with what you've learned before? So, okay, 3.3 video for Monday. Have a wonderful weekend. Enjoy the nice weather. See you guys.